Good morning, children. Welcome back to the video classes. So, in the previous video, we have studied 1.6. Hope that there is no doubt in that. Now, we are going to see one conceptual question. Okay. So, the 1.7. First question. An electrostatic field. Okay. So, what is electrostatic field? That is electric field. Okay. So, let us consider a positive charge. The space around the charge where its influence is felt, then it is called the electric field. Okay. When it can feel the electric field influence. That is, when you bring another positive charge, another unit positive charge, another test charge, then it experiences a repulsive force. Okay. So, the space around the charge where its repulsive force is felt, then it is called the electric field. Okay. Now, we are going to another word, electric field line. Okay. So, this is the isolated point charge. Around that, it has some electric field. Okay. Now, I am placing a unit positive charge. So, positive and positive repel each other. So, it may be repel from here to here. Okay. When I am placing this positive at this place, it may goes to. Then, it will lead. Okay. Are all the points, then it is called the electric field line. Okay. So, what is electrostatic field line? The imaginary, straight or curved path traced by the unit positive charge in an external electric field. The imaginary, straight or curved path traced by the unit positive charge in an external electric field is known as electric field line. Electrostatic field line are lines of force. Okay. Is a continuous curve. Okay. So just see that it will be a continuous curve. That is, the field line cannot have a sudden break. Okay. It does not have a sudden break. Why? Okay. So let us consider positive charge. Around the charge, it feels the electric field. Okay. Now, the electric field lines moves from here to here. Then it moves from to here. Here, there is a sudden break. Okay. So, if there is a sudden break at this region, then the electric field line may go this side or that side or here or here or here or here. Okay. So, which is not possible. So, there is no sudden break. Okay. Second one, let us consider a positive charge. Around that, it has the uniform electric field. Okay. So, when the field lines are moving like this, okay. So, here there may be a sudden break. Okay. So, if there is a sudden break, then we can say there is no electric field, which is not possible. So, there is no sudden break. It is a continuous electric field line. Okay. Do you get it now? Do you have any doubts? No doubt. Okay, next one. Explain why two field lines never cross each other at any point. Okay. So, in the properties of electric field lines, we have studied 5 properties. Among that, we are going to take only 2. Okay. So, positive. Okay. So, electric field lines repel each other. Okay. So, positive, the electric field is radially outwards. They never intersect each other. At the same time, when we are going for negative and a negative, once again, they repel each other, but the electric field lines are moving inwards. Okay. So, when we are going positive and negative, okay. So, the electric field lines starts from positive and terminate at a negative. Here also, it never intersect each other. This is the first property. The second one. So let us consider a positive charge and a negative charge. So electric field lines starts from positive charge and it terminate at a negative charge. Okay. Now at this point, I want to draw a tangent. So the tangent may goes like this. Okay. Suppose when I want to draw a tangent at this point, then it will be moves like this. Suppose when I want to draw a tangent, it will move. Okay. So this is the third property of electric field lines. The tangent to the electric field lines gives the direction of electric field at that point. At that point. So at what point I am drawing the tangent? In that point only it gives the direction of electric field. Okay. But by combining these two, what they are asking? Explain why two field lines never intersect. That is explained. Or why? Okay. Suppose positive. If any of the case, positive, negative, positive, any of the case you can take. Suppose electric field lines like that. It intersects at a point. Okay. So at a point, we can draw one tangent which gives one direction. Okay. Here at that point of intersection, we can draw only one tangent. Suppose that tangent is acting in this direction. Okay. So it maybe gives the direction of nearly the direction of this one. But what happens this one? It does not give. Suppose I want to give you a tangent at this point. Okay. So this may be given for this one, not for that one. So which is not possible. Another way, at say a single point, we cannot draw two tangent. So that's the electric field lines never intersect each other. Okay. Do you get it now? Do you have any doubts? No doubts.